Okay, so that then gives us our first step of the cycle, namely how are we going to pick neighbors? Well, we're going to compute this improved or corrected pairwise distance function and choose its minimum. That gives us a pair, and now we consider those to be neighbors. We join them, and now we're going to replace them by a new node, let's call it C, that links them together in the tree. And we want to, again, choose this in such a way that the assumptions of our algorithm are satisfied so that we can just do it again exactly the same iteratively over and over again to build the whole tree. So to make a long story short here, you can picture this as the following. Let's say we have some kind of tree structure. What's going on? So we have some funny tree structure like this that is the hidden object that we are trying to construct. And let's just say, for the purpose of argument, that these are labeled X, Y, Z, W, and our analysis in the first step picked X and Y as neighbors, okay? And they actually are neighbors in this hidden tree structure, so that it picked the right pair. So now we're going to replace X and Y by a new cluster C, and we want to pick it such that it will allow us to just iterate under the assumptions of our additive distance metric. So actually the simplest way to do this is simply to choose this internal node that joins X and Y as C. So it's basically like, once we join X and Y, we compute distances from C to Z and C to W based upon determining the location of C from the distances for X and Y to all these other nodes versus to themselves, right? And we can, in fact, do that in a very straightforward way. I think you'll see that if we can, in fact, compute those distances such that we get C located here relative to all the other sequences, we can just apply our neighbor joining algorithm again, right? And it'll pick, basically, again, a pair as the neighbors. I mean, there might be a lot more other sequences connected out here, right? We just apply it over and over again in this way.